Hey, there you are! This week on the Weekly Breakthrough, we have a gene editing with a new technique called CRISPR. I'm your host, Bea de la Cruz, and this week's topic is CRISPR.
Hey, yo! Now, what is CRISPR? It is a revolutionary gene editing technique that enables scientists to snip out of a piece of any organism's DNA quickly, precisely, and cheaply for as low as $30. It was developed at the University of California, Berkeley in 2012. CRISPR offers great promise because it could provide a true cure for debilitating hereditary diseases.
Yeah. Hi. It is different from traditional forms of gene therapy in one key sense. CRISPR can be used to edit genes on the human germline so that those changes are passed down through generations, permanently altering the human gene pool.
Now, what has CRISPR already done? CRISPR is already being used to make certain crops invulnerable to killer fungi. And scientists have also created a strain of mosquitoes with malaria-blocking genes that the insects successfully pass to 99.5% of their offspring. But the technique's the most promising application is a potential cure for hereditary diseases. That seems simple enough, doesn't it? But are there any negative effects? Yes, researchers in China have attempted to modify the germline in dozens of human embryos, hoping to snip out the defective gene that caused a deadly blood disorder. The study caused a shockwave in the scientific community, but also highlighted the practical difficulties of DNA editing in higher organisms. Of the 86 embryos used, all of which were non-viable, just 4 manifested the new gene designed to replace the new defective one. Worse, there were inexplicable mutations in the genes that were targeted by the researchers.
So, what do scientists fear? The first is whether CRISPR can be used safely and without causing unintended genetic changes. Even the best genetics admit they have only scratched the surface in their understanding of human DNA and the effects that CRISPR might have on a person's 20,000 to 25,000 genes, which interact in still mysterious ways.
The larger question, of course, is whether scientists should be tinkering with the human gene pool at all. At some point, researchers could switch their attention from curing hereditary diseases to editing supposedly desirable traits into a person's DNA, such as high intelligence, tall stature, or blue eyes.
So, what are your questions? Do you have any? I'm sure you do. So, anyways, if you do you think we are messing with something only God should do? Hoping for your opinions. Thank you, and that's it for the Weekly Breakthrough. Woo!